Lesson 15, surface area. Before we begin this lesson, we need to do a little bit of shoring up on some details and some vocabulary words. But before we even get into this, we need to talk about our transition from 2 dimensions to 3 dimensions. And here, I have a square post-it note on my table here. Now remember, if we were to find the area of this, we would multiply the base, lowercase b, times the height, lowercase h. An area would be base times height. Okay? Now, that's all good and well whenever we're in 2 dimensions. But once we get into 3 dimensions, this lowercase b, the base, please don't get this confused with the base of a shape. Now, here's what I mean by that. If this is just our square, and let me slide that over here, a little off screen, there we go. There's our square. Let me get another square and place it right next to this square. We would still find the area of this shape, base times height. And this gives us something called the base area. And this is capital B for base area, okay? And when we're looking for a base area of a 3-dimensional object, notice that the base area B is in uppercase because it's the area of the entire base. This is a measurement on the entire shape, whereas this linear measurement down here is a minor measurement. It's only the measurement of one side of the shape. That's why we use a capital letter B to designate base area. Now, when we go to 3 dimensions, our base area now gets extruded up. And now we talk about base times height, which we had down here, but now it has an additional height, which is coming out of the table, which is going up. And that additional height is called capital H, the height of the entire shape, the entire 3-dimensional shape. So let's not get base of a 2-dimensional figure and base area, capital B, confused with one another. Similarly, let's not get H confused with the height of the entire object, which would be capital H, the height of the entire 3-dimensional object. Okay, now let's jump into our lesson with this in mind. Some vocabulary first. We call 3-dimensional objects geometric solids. That's what we were just talking about. And that's what happens whenever you have a base area and it becomes extruded or sort of stretched up, or it gets a 3rd dimension of height. Geometric solids whose sides are right angles to the base are called geometric solids, or simply right solids. Here's an example of a geometric solid. Notice how the height, the edges here, make right angles with the tops. This is just a stack of post-it notes, but it's also a very good rectangular prism. The total area of the exposed surfaces on a geometric solid is called the surface area. But before we talk about that, we need to identify what I was talking about before, the prism. If the bases of a right solid are polygons, the figure is called a prism. Well, since all my faces are either a square or a rectangle, this thing is a prism. The area of the bases is called the base area, which is what we discussed at the beginning of the lesson. And the area of the sides is called the lateral area, or the side area. Now, the formula that we need to become very comfortable with is this. SA, which stands for surface area, equals 2B plus PH. Notice that none of these letters are lowercase. So B stands for base area, just like we introduced at the beginning of the lesson. P stands for perimeter of the entire shape. And H is HEIGHT, height of the prism. Let's begin. Surface area is 2B plus PH. Base area of this shape right here. I'm going to call this shape, this side right here, my base. The area of that base is 5 by 2. So base area is 5 times 2. Notice that to find the base area, I did lowercase b times lowercase h. That's equal to 10. Perimeter around the base. 5 plus 2 plus 5 plus 2. Finally, h, height, the height of the entire shape, which is also the distance between the two bases. If this front is my base, then that means the face that we can't really see in the back is also my other base. The distance between those two, which is this side right here, is 2 inches. Now we take our 10, our 14, our 2, plug into our equation. So here we go. SA equals 2B, but B is 10. Plus perimeter, which is 14, times height, which is 2. 2 times 10 is 20. 14 times 2 is 28. Finally, add the two together. 20 plus 28 is 48. Now this is surface area, so we know it's inches squared. Let's try another example. Here we have what's called a triangular prism. The reason it's a triangular prism is because the base of it is a triangle. So the triangle is going to be my base for this one. So I have SA equals 2B plus PH. My base area, 1/2, notice this, lowercase b, lowercase h. In this case, I'm going to call lowercase b 3. That's the base of just the triangle. If we ignored that part for now and just worried about that triangle, it looks like 3 is our base. I'm going to call 4 the height of that triangle. Let's see, we have 3 times 4, which is 12, and half of that is 6. So my base area is 6. Let's go after perimeter of the base area. 3 plus 4 is 7, plus 5 is 12. Finally, the distance between the two bases. Please don't think that 4 is your uppercase h. Notice it was our lowercase h, but these are not the same thing. The height of the entire shape, or the distance between the bases, is capital H, which is this guy right here. It's how far the two bases are separated to. SA equals 2B, which is 6, plus P, which is 12, times how tall it is, 2. 2 times 6 is 12, plus 12 times 2, 24. Final answer, 36, and we're in feet squared. Let's go to the back and look at our examples. on the back. And we will start there on part 2 of lesson 15.